Hi, everybody. I'd like to begin today by acknowledging the Gadigal people of the Eora Nation, who are the traditional custodians of the land where I live. We value and recognise their deep connection to land and water, and we pay our respects to their elders, past, present, and emerging. And I extend that respect to Aboriginal and Torres Strait Islander people joining us today. Everybody, welcome to this joint WIZE Alliance and SUEZ webinar. My name is Sean Cohen. I'm the Senior Manager for Smart Water for SUEZ Australia. And I'd like to introduce Mateu Crespi-Alemany. He's the International Operations Manager for Smart Metering for SUEZ globally. Mateu is going to talk about the WIZE Alliance, the open standard technology platform that we use for digital metering projects, SUEZ and our global experience deploying those projects and some of our history deploying them through Europe and around the world. And then I'll talk a little bit about the Australian context and some of our projects here. If you have any questions as we go, please type them into the Q&A box. If you're not from Australia and you'd like to make fun of my accent or the state of our federal government, there'll be a form at the end of the presentation. Mateu, I'll hand over to you. Thank you.
Thank you, Sean. Good morning and good afternoon to all, and welcome. I'm going to give just a quick glimpse on WIZE technology and how we got there at the global level and a bit of the footprint before I pass it back to Sean. So let's just get started. First of all, I would introduce in a few seconds, we are working at SUEZ. SUEZ is a big company specialized in water recycling and waste. 100,000 people, almost 500,000 of customers. So if we look a bit more in detail on the water part of the business, we have a small line of business for smart metering, in which I'm currently working. And up to date, we have more than 6 million smart meters being deployed worldwide with a huge footprint, mostly in Europe and expanding in other countries. And now we'll see a bit of it. But what I just wanted to say is that it's not something new and it's not something we're trying. It's no new technology. It's something that has quite big numbers behind. We have around 250,000 of new smart meters being deployed every year. So it's something that it's really at industrial level mostly in some European countries. So how that it all started? Basically, the key milestone was in 2005 when the European community decided to open the 169 megahertz band and to allow it for remote metering. That's where SUEZ saw an opportunity and decided to invest in developing and trying if water smart metering would be a suitable usage for that band. So we first got our first solution in Paris, as a matter of fact. We made all the south bank, all the south half of Paris with that solution. We saw it worked. Then we had a small deployment in the world, it was expanding. But another key milestone was in 2012, where GRDF, the national French gas distributor company, was after making several tests and pilot on the technology for a broad deployment of 11 million meters. After several testing, decided to push also for the 169 megahertz band. And that's when SUEZ and GRDF decided to join efforts, and not only to have a solution in the 169, as I said, but also to make it open and to push for it to become a standard. So it was not open just because we wanted to open, but because it was based on a standard. So through the French standardization body, AFNOR, we went to the European Commission. There were some expert committees, and at the end, in 2018, it was published, a European norm that established that the 169 megahertz solution was becoming in a standard, which was fully published, fully open. So anybody can go to the norm, can read it, and can develop standard solutions based on the 169. In parallel, just 1 year before, GRDF and SUEZ, in order to promote the usage of this standard solution, we created the WIZE Alliance, which is, let me pass to the next slide. And what's the WIZE Alliance? Basically, it's an open organization who has several objectives. First is the promotion of this technology. We would like as many companies as possible using it. Then it's to export it to new markets. I mean, understanding that it's European, we wanted to promote its usage in other countries to facilitate other regulators understand and let us adopt for other companies, to keep on participating in the standardization committees and working groups, and also to promote internally and externally with the network of water, gas utilities mainly, the expansion and usage of such a solution. That was from, let's say, a commercial or company point of view. If we go into technology, and I won't get much into details, but basically what we were looking for was first to take advantage of the low frequency we are using to have very long range. And here we're talking about kilometers, 5 or more. Another point that we were very obsessed with was to make sure that everything is interoperable. We want to make sure that when you scale up in volumes, you can change any piece of the module without any impact on the rest of the value chain. And something that was very important for GRTF, and it's more and more common in the water, is to have a very long battery life. As we are extending the lifetime of the meters, what we want is that any electronics within or on top does not stops us for having very long replacement strategies. So up to date, we are with minimum of 15 years and with optimal 20-year battery life. And also what's important is when we discuss about LP1s and any technology that is deployed for connecting IoT devices, what we see is that the main user when there's deployment are smart meters, be it gas or be it water. At the end, we are putting on the table the most challenging scenario, because we have the biggest density, the biggest numbers in the city. And also for the water, it's true, we have the most unsuitable places. I mean, history tells us that we have a tendency to install meters in places that are not the most suitable for connecting devices. What did we get? I mean, when we created the alliance, we didn't know how far we would get. At the end, it proved to be a success. We have around more than 40 companies as for today of any kind, technology players on the IT, on the hardware, on the radio communications. Also, we have utilities and service companies. So today we can say we have an open platform, interoperable suppliers. That's what we wanted, that anybody can jump in or opt out without breaking anything or impacting the rest. And I would say something that's quite important, that all these solutions have been, at the beginning, as I said, have been pushed or designed by utilities. So I would say it makes them more suitable for utilities, because there are many thinking and brainstormings that have happened before designing. So in that sense, we can say that the whole solution is quite well tailored for a utilities perspective. So this is going to be the most technological slide in my presentation. So at the end, what we are proposing in terms of technology is an open solution, as I said, based on an European standard since 2017. As for today, we have 5 water meter brands with the protocol available. So it depends in every country which brands are available or are present commercially. But usually these 4 or 5 brands tend to be in most of countries, 1, 2, at least 2 of them or 3 of them. So it makes it quite easy to find quite a good portfolio of meters to go with. It's fully interoperable. I mean, all of them have the same data model, they have the same data, which is a problem that we see now in other technologies, when we can say that all of them fall in the same technology umbrella, but then everybody is speaking a different language, a different data set, a different configuration modes. in WIZE, the good thing is that there's the application layer inside. So all of them speak the same language. So in terms of changing meter, of integrating different brands of meters in the same street, in the same village, in the same city is not a problem. All the network solution and IT solution, it's consistent, it's unique. There's no impact in adding or dropping out brands. I will go a bit in next slide, a bit on the detail on the benefit of the 169 megahertz band with respect to the other bands. As I said, 15-year lifetime, it's something we wanted for 24-hour daily readings. We have customers that for them it's enough one daily reading. So those ones can go much farther in terms of lifespan. Another important thing is that this technology is going to be supported and guaranteed until 2041 or 2042, depends on the month you're talking. Why? Because we have huge deployments that should be ending in 2026. So if we put the last meters in 2026 and we have commitments of 15-year lifetime, that takes us to 2041. So until 2041, this technology will have to be supported by all the players, all the suppliers. As I said, the track record, it's quite huge. We are talking about 4, 5, 6 million meters. It depends on the country and on the exact solution, but WIZE has a huge track record that proves that things are going well. And we will see in the footprint that we have customers that are already starting the renewal or defining the renewal after 10 years or 12 years in the first cases, because we were talking about the first generation or the first solution that were installed 10 or 12 years ago. We have incorporated, I mean, it came with the last version in 2016, the downlink that allows us to operate fully in a remote way, the configuration firmware update. So anything that we need to change, we don't need to go to the field anymore. And as I said, there's the data we are collecting, it's fully optimized. We are always trying to find an equilibrium, a balance between the volume of data we want to recover and what it means in terms of battery expense. So at the end, we try to figure out what's the best balance in terms of value for the water company. And here it's the last technological slide I want to share, and it's why the 169 megahertz solution would be better than others. So basically, and that's physics, it's not the commercial speech. The lower the frequency they use, the better penetration you have through walls, through any obstacle in the middle. So this, when we compare it to any solution like 868 megahertz or 433 megahertz, or if you go above the gigahertz bands, then you see that when you're dealing not with the outdoor coverage solution, but you have obstacles, because you either have the mirror in a pit or the mirror just behind a wall, or you have a very dense urban area with plenty of buildings that are obstacles in radio frequency, then it's where you see that the benefit of using such a low frequency. And I would say that's one of the important characteristics of this solution, that with few network elements, it allows you to cover not only long range, but getting deep indoor for whatever you happen to have the mirror installed. So as for today, the footprint, it's quite concentrated in Europe, as a matter of fact, and now we are expanding in both America and the zone of Asia Pacific in any kind of environment. And we're finding really dense areas in some area Pacific cities that we are testing, and we are checking how it would be a full deployment. And then we have other more sparse and more non-dense areas that we are also seeing huge long range cases. So now I will go through three, I would say, very showing cases. And one would be Malta. Malta 10 years ago, we started deployment with the first version of the WIZE solution. Right now, as they have a meter base that it's arriving to the end of the life, I would say that what's really telling is that after 10 years, rather than seeing, or I mean, they have been looking at our technologies, but after that, they came back and they said, we think we would like to keep on. And we just started the deployment or the upgrade to the latest version of the WIZE protocol. And this is something that has been already started and is being deployed. So during the next 12 or 18 months, it's going to be a network renewal. We've made the IT part upgrade, and everything is ready just to start deploying as the meters arrive to at the end of the lifetime to the new protocol. And that's a proof that during this last 10 years, the 275,000 meters they have been providing a good performance. The customer has been fully satisfied, and now is ready to keep on doing that with the next protocol. Another example that is in the middle of the deployment was started in 2016. It's Barcelona, almost 1.5 million customers. Now, as I said, they just overpassed the 50% of the deployment. Here, the key question was network management and customer engagement. So after 3 years of deployment, where they had already quite a volume of meters in the field and customers connected, they made a touch base, a point where, see, okay, are we able to confirm to everybody, stakeholders, regulators, that we are really providing what was promised? And the answer was yes. When they said, yeah, whatever we have installed proves to be delivering 99% network performance, meaning almost all meters that were connected are still connected, are fully providing the information, which means saving a lot of bi-monthly reads, manual reads. We also start to grab the benefits. We are reducing work orders. We don't need to go so much to the field to check complaints, disputes with the customers, because we have plenty of information to analyze and to discuss and share with the customer. We have identified quite a huge number of frauds. I mean, 0.24% may not look a lot, but it's quite more than what we expected. Thanks to the visibility in detail of everything that happens at the meter point. We have been able to raise a lot of overconsumption alarms that previously were very difficultly tackled, because we only had one data per 2 or 3 months. Now, as you have more data, you can spot very quickly if there's a surge on the water consumption. And also, we are tackling the leakage. I mean, we are seeing that around 6% of meters in a year, they have some leakage event that allows us to launch a communication strategy for whatever channel is available, and producing a real impact, not only on the bill, but in the water conservation as a city in all. No? So at that point, after 3 years, Barcelona was able to confirm that the benefits were getting collected, and it made sense to keep on deploying. And just a comparison, Barcelona is actually managing the water for 23 municipalities. And what we've seen is that every time we deploy in a certain area or municipality, just for the municipal consumption endpoints, we see quite a huge reduction of water usage from before to after AMI in implementation. And just by managing the information that you are able to collect, you share it with the customer, and the customer is able to identify leakages, to identify consumption that were unknown at that time, and to make them curb the consumption. Just 2 examples of what we're doing in Barcelona. The fact that we have smart metering data. I mean, ideally, what you would like to share the data on a portal, or to share through SMS, WhatsApp, or any electronic channel or email. Sometimes that's not the case. Sometimes the customer doesn't have an electronic contact available. So, but what we see is that even in that case, you can define a strategy to communicate. So that's an example where a customer had a little issue with the meter, so he decided to change the direction, fill up the swimming pool, and then switch it back again. That was, he didn't know that as on the top of the meter, there's a radio transmitter. He was being fully controlled. So we were able to spot it. And a letter was sent saying, we thought, we have evidence that this has happened. Please don't do it again. This could be highly penalized with a huge penalty. And another example is a typical leakage. That's a small business where we see clearly an increase in the consumption. When we look at the alarms, we see that there's a minimum consumption per day, meaning the meter is never stopped. So we were able again to send in a notification, a contact to the company. And after some days, when they got notified, they were aware and they could correct the leakage and get back to normal consumption. What I'm meaning is that you don't need to have all the technology behind around customer engagement. You can also find a way to impact on the customer. If it's through technology or IT channels, perfect, that's much quicker, that's perfect. If not, you have to find a way how to make the customer aware if that's important for the company. And the last case for me, it's also the last where we've been working more intensely is Paris. Paris, as I said, in 2005, we started with the first transmitters working on the 169 megahertz. That was the first of the first. That was our first project. In 2016, 17, they decided that as it was approaching the end of the lifetime, they need to renew it. There was a tender, there was several pilots with several technologies. And again, we were selected for deploying. And this time, not only the South Bank, but the whole of the Paris zone. And the only thing that was added or had to be developed was they were requiring a static meter. So we selected, we tested and analyzed several options at that time available in the market. We chose for one static meter in partnership with a manufacturer. We included the radio technology and the WIZE protocol within, and now we are deploying it. And it's almost finished. We are just closing the small holes with the difficult meters that, as all huge deployment they are faced with, you might be facing. So we can say that now we have around 90,000 meters already deployed, fully compliant with the customer expectations, and getting all the benefits of the 169 band. And my last slide is just, okay, how, if I'm a company, how could I buy, sell, get benefits of that from a commercial point of view? As I said, we didn't want to be only open in technology, making it a standard, promoting it, making sure that it's something open for anybody to read and develop on that. We also want it to be hostage-free, no locking in any particular point of the value chain. So basically, when we look at the business model, there are three questions that you must put yourself. Is one, who will own the assets, who will build the assets, and who will operate them? And usually on the endpoints, that's quite a straightforward decision. Who owns usually is the water utility, supply and install. There's not much magic there, and operation and maintenance neither. But in the two other pillars, it's where the question is usually more open and more flexible. And what we see is that you can own, get installed and maintain a whole network. And that would be, for example, the case of Malta. Malta being an island quite isolated from the rest of territories, they decided they would buy the network, they would get it installed by whoever, and they would be operating it. And they've been doing for 10 years that with no specific problem. In other customers, they decide, I don't want to own, I don't want to install, I don't want to do anything. I want to focus on water rather than telecom. So there's always some company ready to jump in that role and make it either at owning or installing and maintaining, meaning the company can own or just use or pay for the service. It's quite flexible. And on the IT, it's the same. You either can own the servers and the licenses and to get installed and to operate by yourself. There are many customers that are ready to take that. Other customers think that that's a challenge, that they don't want to get in that area, and that they prefer to, as I said, to get focused on the core business. So now what we see is more and more customers ask for a SaaS service where all the IT is fully managed by a third party. So they just basically do not have to involve any IT resource on its management. And the best of all these models is that, as I said, it's very flexible. It can be customized to any customer specific requirement. But the good thing is that it can evolve. I mean, you can de-risk the project by saying, I want a service for the IT, I want a service for the network. And then after some time saying, okay, now I see that it's not complicated. I might be getting the reins, I might be assuming the responsibility. So that's what we call reversibility clause. And it's really easy. It can be guaranteed. And we see more and more changing in that sense. Companies that started on premise are going to the SaaS mode, and companies that started in SaaS that are preferring to leverage on their existing resources. So as I said, it's fully open business model, and it can change a long time. It's not something that once you decide it, you're locked in. And here I will pass it to Sean to give us a glimpse of what's going on in Australia. Thank you.
Thanks, Mateu. That's appreciated. So here in Australia, what's our experience? Well, SUEZ has been here for a long time. We provide a lot of water. We're in a lot of places in Australia. In general, in Australia, if you turn on a tap or if you flush a toilet, chances are there is a SUEZ person at the other end of that pipe, wherever that pipe may be. So let's have a look at WIZE in Australia. So the first thing that I would like to say is standards are important. I'm not going to make you read all of those bullet points, but all that work in Europe translates into the Australian regulatory environment. So ACMA, the Australian Communications and Media Authority, which is the regulatory body for all radio equipment in Australia, everything that uses radio. So your Wi-Fi gear, your cell phones, your walkie-talkies, your Bluetooth headsets, everything that has a radio is regulated by ACMA, looked at those standards and made a determination that, in consultation with the WIZE Alliance, that WIZE, or Wireless M-Bus, the standard on which WIZE is based, is a fixed point-to-multipoint land mobile radio system under the existing legislation. There's a link there that I'm happy to share with everybody if you have trouble getting to sleep at night. So what does this actually mean in practice? Well, in practice, per deployment or per project, there is an application fee and there's an annual fee. It's not a lot, in the order of hundreds of dollars per year, but it is a set of forms to go through. And what do you get for that? Well, you get guaranteed exclusive use of a piece of radio spectrum, the 169 megahertz frequency, for your project, for that bit of geography. And if anybody else sets up any equipment that interferes with your project, then ACMA, the ACMA, is the enforcing agency. So you get to call them up and they will go and shut down. They have enforcement powers that they will shut down other people's equipment if it's causing interference. Now that's in theory. In practice, in our Australian projects, production deployments, pilots, trials, demos, we've not experienced any kind of interference. And I'll talk in a minute about why we think that is. So ACMA is last did their review of WIZE in Australia in 2020. The result of that review was a reduction in the paperwork that was necessary and a reduction in the fees, to the point where now the actual work required is quite straightforward. I would just also like to commend ACMA for the work that they've done. I was involved in some of the earlier meetings with WIZE Alliance, for their vision and collaboration in allowing this technology in Australia. And the attitude was very much, if this is an international open standard and it's in use elsewhere in the world, and there is some community benefit that can be had in Australia, and it's not stepping on anybody else's rights. It was a default to yes rather than a default to no. And I think ACMA should absolutely be commended for that attitude. So let's take this theory and put it into practice. What does that look like around Australia? So if you wanted to set up a 169 megahertz, a WIZE project, would you be likely to actually have any interference? So we'll just, as a reminder, if everybody remembers, in the standard, a WIZE project can use any one of 6 possible channels around 169 megahertz, 169.4 to 169.475, all 12.5 kilohertz wide. And any one of those 6 channels will allow a project to be deployed. So we did the work to check where in Australia that might be a constraint, where somebody else might have an interfering application. And there's the map, if it's come up on the screen there. So there are precisely 8 specific locations that that have what's the word? Conflicting users on one channel. And then there is one statewide license for an organization in WA for another channel. So the vast majority of Australia it's completely free spectrum. It's completely free space. And if you deploy a project, you won't have any kind of conflicts anywhere at all. The worst case would be some specific points in Western Australia where you would only have 4 channels out of the potential 6. So in practice, we've not had any constraints on our projects, and you shouldn't expect to have any constraints on yours. So with that in mind, what is the future of radio licensing? The status quo situation today with the licenses per deployment is really not onerous. It's not expensive. It's a marginal cost to a project. It's not a lot of administrative burden, but it's not exactly in line with how things are in the EU. So in the EU, they have what we would call in Australia as class licensing, where the equipment is licensed rather than the project, in simple terms. So if you're in the EU, you go to Harvey Norman, you buy a piece of WIZE equipment, you plug it in, you don't really have to worry about it. Much the same way that we treat Wi-Fi equipment in Australia. The only challenge with that is you can do that, but your neighbor can do it, the guy down the street can do it, the guy upstairs can do it, somebody setting up a base station downstairs can do it. So you start to have potential interfering applications. And that we see that play out in work that we've done in Australia using other wireless technologies. It's in people's experience to have poor Wi-Fi because there's too much Wi-Fi contention in an area. Certainly in the last apartment that we lived in, that was the case. Bluetooth headsets have interference, LoRaWAN networks have interference, and so on. Luckily, we can point to the European experience and say, is it likely to have that same kind of contention, that same kind of interference on the 169 megahertz band? And the European experience is no. The amount of interference that they've had on that band, under the class licensing regime, has really been negligible. So we're not really concerned that there would be interference with a change of alignment. And the WIZE Alliance position in general has always been supportive of policies that reduce barriers and overhead. In general, any cost or burden to a project is passed on to the end users. And in these cases, those end users are customers, are residents, are ratepayers. So any cost to a project ends up as a cost to a ratepayer. So we'd like to keep those as low as possible. So finally, let's look at some specific production deployments in Australia, just in general terms. Firstly, a project with Unitywater on the sunny coast in Queensland. So Unitywater, wow, that is a tremendous amount of bullet points. I do apologize. Unitywater, just over 350,000 total connections over a reasonable sized service area. Unitywater started a project around the Maroochydore area called the Digital Neighbourhood program. The goal of the project was to create a digital proving ground where they could test a variety of different digital technologies, not just in metering, but network sensing, modeling, network optimization, and so on, up and down the stack. So everything from metering to SCADA to other types of IoT sensors and so on. Devices on two IoT networks were deployed, a WIZE network and another one, in an area that supported around 10,000 customer connections. So in general terms, the project is finishing its deployment now, but in general terms, the WIZE technical performance was exceptional, certainly in line with the EU experience. That particular part of Unitywater service area has a lot of high rises, apartment buildings, hotels, and so on. So performance in pits and in basements was all exceptional, really in line with modelling and expectations. And we're already starting to see some of the early results from those, as Mateu mentioned, on-premises leak detection being an easy piece of low-hanging fruit. The purpose from Unitywater's point of view was to give them a foundation to do the next generation of digital operations. So they've set up a data science and analytics team, and all of these, this is just one piece of that puzzle, but all of this data gets pulled into that team to create an integrated dashboard project. And they've published some material on their vision for that part of the world, which is really fascinating. I recommend everybody go to the Unitywater website and have a look. The second project that second project that I can talk about today is Goulburn Valley Water, which is the utility for, I've got a map on the top right, for in Northern Victoria, which is a very different kind of built environment to Unitywater. So you can see about 65,000 total connections, but the service area is more than 20,000 square kilometres. So some parts of that quite sparsely deployed. The Intelligent Metering project is a POC to a full deployment. And the goal, the founding principle of the project, the philosophy, is to measure all the water all the time. So a heavy emphasis on metrology and actual measurement improvements of the water itself. And you can see a photo. It's actually the same meter that we used in the Paris deployment, which has fantastic metrology, and an IoT network that could support sending data in a robust and reliable way. In the case of this project, Mateu mentioned earlier different operating models. So in the case of this project, SUEZ is actually operating the network as a service, but that's not by any means a requirement of the project. It was the preference at the time and something that can transition in the future. Outcomes to date, so the metrological performance of the meters has obviously been fantastic, certainly in line with plans and expectations. The WIZE network performance, where it's been deployed so far, has been exactly as modelling or better than the modelling as predicted. So meters in pits and basements and so on has been fantastic. And I would just like to commend the Goulburn Valley team and our partners on that project for the project itself. All the delivery KPIs have been basically on track despite COVID, fires, earthquakes, canal blockage. I mean, I'm not quite sure how many horsemen of the apocalypse there are left that we need to face, but the team has done an absolutely tremendous job keeping things on track and within the original project goals, despite all of those things happening. So well done to everybody involved. And finally, even though we're still in deployment stage, not quite done, we are of course seeing a lot of good benefits already in on-premises leak detection and early results from analytics. So Goulburn Valley has started to publish some of those results. I encourage everybody to have a look. And finally, I'd like to make a couple of comments about the WIZE ecosystem in Australia. Mateu had this slide up earlier, and I think it's important to make sure that, I guess we'll focus on the metering, to make sure that that it's recognised that these partners, being able to just select equipment and deploy it without having to invent anything was a really powerful tool that we had in our toolbox in starting these projects, particularly in Australia. I'm a massive nerd. My 9-year-old daughter asked for a soldering iron for her birthday. I love building things and inventing things and gadgets. I love all of that stuff. I really do. But I'm also an engineer, and I would never deploy something 10,000 of anything in the ground anywhere unless it had been in the ground 10 years somewhere else. I think as engineers, we have a responsibility to manage the risk on our projects, and having this ecosystem of partners in the WIZE Alliance that can refer and bring technology that is completely proven in other parts of the world, not something that needs to be invented or developed for a project, is really, really powerful. And I think we have a lot to thank for those partners to be able to bring off-the-shelf technology to a project. So There we go. A special bonus points in the Q&A to anybody who can recognize what the yellow boxes are in the bottom left. So thank you everybody for your attention. We've had a couple of good questions come through in the Q&A already. So I'll start asking Mateu some of those in a moment. But if you haven't had a chance, hit the Q&A button at the bottom of your screen, and anything that you have in mind that you'd like to ask, please type it in. So while you're doing that, we'll start working on the questions that we have already. There's a few good ones coming through. So Mateu, this is a question for you, I think. Can you share a figure in terms of the volume of water saved by the fraud and leakage detection capability of the AMI project in Barcelona? Pardon me.
Okay. Actually, that's something that we produced. I mean, the Barcelona Water Company produced a paper that was then afterwards published with experience in 2019. First of all, on the fraud, I mean, the volumes of fraud, fortunately, are not big. So to put them, to compare them with the total volume of the water generated or water saved, it doesn't make much sense. We're talking about 1 per 10,000 smart meters. That during a period, let's say a year, we might find a fraud. We saw 2 types of fraud: people that were fooling with the meter, changing the direction or taking it away, and closed contracts that the water company decided to leave the meter working, even if it's closed. And what we found out is that in a closed contract where it's supposed to be nobody living or nobody consuming water, sometimes we experienced that there was a water consumption that was triggering an alarm, and we were able to go there and really check that there was somebody actually consuming water in that closed premises, be it the owner or the neighbor or whoever. So I would say in fraud, very small number, not comparable, and talking about units per 10,000 of meters in total. On the leakage, we had quite a good analytics. First of all, what we analyzed was the average minimum flow, and that's important because in the WIZE protocol, we don't have a yes or no leak alarm. We have a leak alarm that tells you the minimum flow, so at what flow you're never going lower than that. So this tells you the size, the magnitude of the leak. So in overall, in that 2019, in the 33% of the meters in Barcelona, we had an average flow of 157 liters per hour, it's huge. So what we did to have a more clear vision of what happened, we took away all the big diameters, all the commercial and industrial customers, and we focused only on the small diameters, the N15 and the N20. And this took us back low to 44 liters per hour, which it's still big, but it's already something that you can see as realistic happening in a domestic dwelling. Another thing that we looked at it and we analyzed is the time to repair. I mean, how long it takes since we notify the customer until we see that the leakage goes down and disappears. That was a little less than 8 days. So from all this information, I mean, it's difficult to say the impact you have because you never know if the leakage has been corrected because you notified or the customer already knew it and it was just getting it confirmed from us. But we were talking about 500,000 cubic meters had been saved if we took the average leak flow and the time to repair as we measured it in Barcelona.
Thank you, Mateu. And if anybody is interested in seeing the more detailed version of that case study, then put a note in the chat or in the comments and we can send it through. Okay, we've had a couple of questions around connectivity. I'm just going to pick one. How do you deal with wide areas in terms of connectivity? So I'm presuming that is referring to coverage gaps or specific coverage issues in a project deployment.
Okay. So basically what we do when first of all, I would say in a deployment, we make a a radio propagation analysis. We make a selection of sites where we would install concentrators and network elements. Then we would deploy, and at the end of the deployment, or during the last phase of the deployment, we start checking and getting results of how good it is. And then, of course, we may find zones where we lack coverage. So what do we do in those cases? Basically, we have several options. One is if we see that we have a general lack of coverage in the zone, meaning that one whole street is badly covered, we would either densify the network, add a new element of the concentrator, or we would improve the network by using some type of directional antennas. Another option we have at hand also is to play with the power and the bit rate. I mean, in the technological aspect, there are many parameters that you can play that helps you to extend the range. Why don't we do it at the maximum for all meters? It's because this usually has a higher consumption on the battery. So there you must find an equilibrium. So basically we start by default with something standard that gives us quite a good gap between what it's our commitment and what the battery can afford. In those cases where we have the need to improve, we might increase a bit the energy consumption to make sure that the radio link is better.
Thank you, Mateu. And I'll say from the Australian experience in general, the projects that we've deployed and the trials that we've deployed have matched very closely the propagation study, the desktop study that we do of, we have software that plans the propagation of when you put a base station in a spot, what kind of coverage do you get? And that tracks very closely with the real life experience. All right, next, we've had a couple of questions about specific features of devices. So we'll take one of those. What is the data storage and retrieval capability of the meters? And I think let's talk about that in terms of general WIZE devices around data storage and retrieval.
Okay. First of all, I would say that as WIZE works in the broadcast mode, meaning that one meter does not speak to one concentrator only, so it tries to speak to several. In our project, we have what we call a redundancy factor. We make sure that any meter can speak to several concentrators. Why that? Because like this, if we have a problem for any reason, because the supply goes down because of the lightning or whatever reason, and we lose one concentrator, we always want to have as a backup another concentrator just around the corner, ready to have a dialogue with the meter if required. We have a very low loose frame rate. So we do not usually implement storage and retries. Why? Well, because we think that for the few frames that or messages that we might be missing, to implement a retry, and the retry means spending more battery, spending energy and reducing the lifetime of the battery, doesn't have a good return on the expense. So we have a minimal, we have capacities to keep the data and send it several times, but after one day, I mean, for example, when we send the index at midnight, we send also the index on the last midnight, just in case yesterday we didn't receive the data, but we don't have a track longer than that, because we think that the benefit of retrieving data from far behind in time doesn't compensate the cost of retransmission and the cost of the battery consumption.
Thanks, Mateu. We've had a couple of questions about costs, so I'll take this one. A few questions asking what is the cost per connection or the cost for a project in Australia. So I'll answer for the Australian context, and then Mateu can give a broader perspective. So in Australia, there's two costs, or three general buckets, but two main costs that need to be considered. So one is the cost of deploying the network, so the base stations the concentrators to be installed and mounted, and the cost of looking after those. That's one area. And then the second cost is the cost of the meters themselves, the smart meters, the devices, the endpoints. So the meters themselves range in cost with basically with features and functionality and design. So a single jet mechanical meter with a plug-in module is by design going to be cheaper than a fully integrated static meter, because they have different costs involved in them, different costs of manufacturing, different performance and features, and that range also depends on the features of the specific model that you like. And I think anybody, if you talk to your local distributor for water meters, they'll be able to give you guidance around local pricing. The cost for deploying and looking after the network is typically a small portion of the cost of the whole project. We would estimate 5% or less of the cost of the project would relate to network build out and operations. And then the cost of looking after those base stations per year is, we typically estimate each base station on average per year needs 1 day of effort towards it. So might go 5 years without any kind of attention. The design life of the base stations that we use, so we buy our gear from Curlink and Sagemcom. Base stations that we use, the design life is 15 to 20 years, and we budget to have 1 service day to each base station per year. Let's say they go 5 years. Then at the end of 5 years, maybe it's struck by lightning or hit by a truck, or it's attached to a building that's getting demolished and needs to be moved. So you have to put a few days of service, a few days of effort into it. So that kind of averages out. But if for the people that are interested in specific projects and have requirements that they want estimated, absolutely, please get in touch. So Mateu, do you want to make any more broader comments about cost?
I would say you wrapped it up quite well. I mean, I'm not able to give a cost estimation. I usually have a tendency to say first, let's see your case, and then we will be able to give the elements. It's not the same in a rural area or in a big city where the density is quite huge. In the meters, I would say that every country has a specific meters. As we see in Australia, the meters are not exactly the same, and in Europe, so there are deviations in prices that you might see. And on the IT, at the end, it's all the same. No? It depends on how you want to manage. We see some customers wishing to have on premises, which changes completely the costing spreadsheet, or even if it's in a SaaS mode, they want to have it in some specific platform integrated with their platform. I mean, there are quite many elements that can modify or adapt the final costing.
I would just add to that, we do try and make a general point of, for projects where utilities, if you have a project of above a certain scale, so in the tens of thousands of endpoints, you've almost certainly reached the scale where it's worth taking some activity in-house, because anything that you don't do yourself, you need to pay someone else to do. You don't get any activities for free. And I mean, this is true of any technology. If you do a WIZE project, LoRaWAN, Sigfox, NB-IoT, whatever the project is, the more you have as a service, the more you have to pay a third party to provide that service. And we do encourage everybody to consider the scale that they're working on when they're doing that calculation, because services need to be paid forever. There's no, you don't get to pay them down over time. And that's a commitment for 15 years or for 20 years is a big commitment. And if you can in-house a particular set of skills, it makes you more independent, and it also saves money for operations in the long run. I'll move on. I think we've got time for one more. So I like this question. What was the longest line of sight distance that was achieved with WIZE between an end node and a concentrator in Australia? I can share that. In Australia, it was about 9 kilometers in a metropolitan environment in a city. and the concentrator at one end was on the side of a hill at the outskirts of the city, and the meter itself was in the CBD area in a basement metering room, and we have no idea how we got 9 kilometers out of a basement metering room and then across the city. That was certainly an outlier, and we would not design a project with that in mind. Number one, because it is an outlier. We do get excellent performance, but we don't design deployments using outlier information. And number two, when we design a deployment, we want an amount of redundancy in the network. We want to make sure that, look, if one concentrator, gets struck by lightning or gets hit by a truck or something of that order, that there are 4 or 5 other concentrators, or at least 1 other or 2 other concentrators that are picking up the transmissions. So we find that we get to the earlier point about retransmission. We find that we don't need the retransmission feature because we have that redundancy in the network picking up the transmissions. Now, Mateu, I understand there was an experiment that was done, I think, in Spain to try and see just how far they could stretch the transmission.
Yeah, I mean, no, and our experience says that sometimes we are receiving frames for up to 30 kilometers, but that
don't design for 30 kilometers. That's not yeah, a thing. Please don't do that.
Definitely. And I see a question about the best design distance, and I would say I would rather never put the question in a way of talking distances. I mean, it's very misleading concept. Why? Because the topography and the obstacles play a lot. So when we make a design, we use radio propagation tools that allow us to say, if you put a concentrator here, it happens that you are in a valley. So after 300 meters, you won't, behind the hill, you won't be collecting any data. But if you put the concentrator just on the top of the hill, you might be reaching 4 or 5 kilometers with a certain good visibility. So it's very difficult to talk about distances, and we don't like to talk about radius from the site. We prefer to play on a map with propagation analysis tools, and then we are able to say, this is the network that would be good for this solution. We also take in account the performance KPIs, the SLAs that we have, and according to that, we decide how redundant we want to make the network, and we basically say, produce a customized case-by-case scenario.
Thank you, Mateu. I think we've just gone over time, and we still have more questions to answer. So I think we're going to have to call it there. Thank you again, everybody, for your attention. I know there was some issues with sign-on a little bit earlier. I think, do we have? All right, I'm being told we've got time for one more question. So we'll pick this one out. Is the network platform different from Sigfox? And if so, what is the major difference? So we'll take that as the last question. Mateu?
Okay, I would say there are, I will not think on the one big difference is on the frequencies. I mean, Sigfox is working in ACZ usually, and it's quite above. So you cannot expect such a good penetration from such a high frequency. That's pure technicality on technology. What I would say the big difference from my understanding is on the business model. Sigfox is a multi-customer platform. So you basically pay for a subscription. So first, I would say that the first hurdle you might find is that the network is not customized to your needs. It's a network that has been installed for everybody to use, and the water meters happen to be in the most unreliable places. I mean, it's the most challenging IoT device that can be deployed in the city. That's one question, and the other question is, as it's operated as a general purpose. You might expect that the company that is operating is expecting a profit. So if after some years they are not making a profit, and I was doing an operation of such a network, I would say I prefer not to lose more money. So I may decommission the network. I mean, I don't have any need to keep on losing money. While with your customized network, you can get a full engagement saying, I want this performance for what we design a network, and we install it and we will operate it until it's necessary, until the end of the contract. I mean, it's not a subscription based, it's a customized solution for a specific customer.
Thanks, Mateu. I would just encourage everybody to please visit the WIZE Alliance website and read up on the technology and the background. We mentioned at the beginning, SUEZ is a member of the WIZE Alliance, and we use this technology as a customer. We purchase all of the WIZE compatible technology, the base stations, the meters, the devices from WIZE Alliance members and WIZE compatible manufacturers. And we use it because it works well for us, and we integrate it into projects and deliver those projects. And I would encourage everybody who is either a user of technology like this or is interested in delivering smart water projects to investigate WIZE and get involved and use this technology to your own ends. It's open, it's available to you, and it's certainly something we'd like to see some more of. So again, thank you, Mateu, for making the time. It's very early where he is, so we appreciate it. And thank you, everybody, for your attendance. If you have any follow-up questions, please leave them on the LinkedIn page, email myself, or leave them in the chat that that we've got at the bottom now. Thank you, everybody. Have a good day.
Thank you.